Hello, welcome to the channel. Today we're going to explore how to write Kafka streams from our Clojure applications. So just to be clear, this video is not supposed to be a tutorial on Kafka streams themselves, but we will more focus how to interact with Kafka Stream API from Clojure. We will take a look into a Clojure library that's a wrapper on top of Java Kafka Stream API. And I believe the most important bit from this video will be how to write tests without pain and interact with Kafka from the test environment. So we'll be using TestContainers to start our Kafka locally. So everything will be controlled from the code, and it will be quite fast because we're going to use a feature called reusable containers. So we don't have to start Kafka on each test run. So yeah, I created a simple project. A link will be in the description if you want to check source code. So quickly going through dependencies, Clojure, as you can see, the Jackdaw library is the library that I mentioned, which is a wrapper on top of Kafka Stream API. Then we need this dependency for our tests if we want to use topology test driver. So there is an option in Kafka Streams to avoid running Kafka, so you can just test your stream topology without going through Kafka. But today, as it's more interesting and sometimes it's useful, we'll use a real Kafka in Docker with TestContainers, and the next two dependencies will help us with that. So it's TestContainers and TestContainers Kafka. And yeah, you can ignore this for now, but it's just to enable some logs from Kafka client libraries. So yeah, that's it. Let's jump into our core namespace. So the first thing I want to focus on is these Kafka test containers. So we are going to use Confluent images for Kafka, and I just picked one of I'm not sure if that's a recent one, but it's kind of fresh version, I believe, but you can check if there is a more recent one. And to create a test container, we're going to use this code. As you can see, the benefit of using test containers is actually you can easily switch from Zookeeper to Craft mode. And I believe Craft is now production ready, marked in one of the releases recently. And Zookeeper is deprecated, so eventually we're going to use Craft. But if you want to test it in your test application, that's fine. You can just do it with this property. So just a quick step back, the other options regarding Kafka and how to write tests locally. So obviously you can just use this Docker and something like Docker Compose to start your test environment. In that case, you'll have to run your Docker Compose app or whatever command before you run tests, which is a bit annoying. The other option that we were using for a long time is to start Kafka embedded into our JVM. A nice option, it works fine and it's quite fast since you have your JVM already running. The problem that it's not consistent in our setup with other tools that we use in the tests. So we were using database and it was in Docker Compose. Kafka was embedded, so it was annoying, and YMOC was embedded as well. And now we're basically trying to move everything to test containers. And so far it was going pretty well. So it's just like a single tool that's supposed to start all our test dependencies. One of the concerns was that it will slow down local test execution, because if you do nothing, by default, it will just start fresh containers when you need them. Which could be slow, but there is an experimental option. I think it's still marked as experimental, to mark your containers to be reusable. So for Kafka, unfortunately, you need to set this network to nil to make this working. There is a ticket somewhere in the internet describing this, but yeah, just do this. But basically, this generic option you can use for any container that you working on, and it basically will start this container and it will keep it running. So next time your code requests a container and the configuration is the same, it will be reusing the same container that's available. That's not enough. So it's like you need to enable it from both sides, from the code and from your local test container environment. To do that, there is a properties file, TestContainers.properties. And if I check that one, you'll see that I have this TestContainers reuse.enabled to true. And just to mention, this is supposed to be used only in dev or test environment. In CI, we just don't have this enabled, so containers are starting as they are needed. So that's regarding Kafka test container. Then if we start the REPL, and let me see, give me a sec. Let's load this namespace. So this Kafka test container is just a definition of the container, and then you need to run start function on top of that. And after that, you basically has an option to get some information from the container. So it's you can think about that as like a convenient interface to your Docker container from the code with some additional features. So we can do Kafka bootstrap service, and it will now start the container, and we'll get back the bootstrap service. See this plain text. And now if I do docker ps, we'll see that we have a container that's running for 10 seconds. And the thing with reusable containers is if we remove this line and we kill our JVM, this container will be eventually turned off. But now I can just turn the REPL. So killing my JVM, I do docker ps, I should still see the container. And now if I run the REPL again and reload this and call Kafka bootstrap service, now it's much faster because it was able to reuse the container. So you see no container was created again, and we're still using this one. So this makes tests running pretty fast after you run them for the first time. All right, so that's regarding test containers for Kafka. The one thing to mention is this call here to start is just a hacky way for demo purposes. It should be managed somehow better if you're in your real applications, in your tests. One of the approaches could be just to create a test fixture and just wrap your test with Kafka test container and just run start. So you always know inside your tests you'll have the running container. But somehow like a global state and you just start your container works as well. Yeah. So moving to our streams themselves. So I tried to create two different options. So two different streams. One will be just a simple Kafka stream to start looking at that. And the second one will be a bit more complex, but it's usually used as a classic example of Kafka streams. You can think about that as like a hello world application when you learn programming, and it's called the word count. I modified it a bit. So the idea is usually in your input topic, you're getting the messages with some text strings, like lines of text, and then you parse them into words, and then you create a stream that in runtime maintains the count, how much the individual word appeared in in those messages. So yeah, it's building the state, and after that you produce result to output topic, and you'll see that, for example, for this word was occurred one time and then 2 times when we found that for the second time, etc. But yeah, we'll see that in tests as well. But let's start with this simple topology first. So the key part of any Kafka stream is to define your topology. And as you can see here, we're using this j/whatever, and this is actually a wrapper from Jackdaw streams. And the names are similar to what you will see if you just check Java API. And by the way, there's nothing wrong not to use a Clojure wrapper, but just go straight to Kafka clients, get your Kafka streams dependency, and just start writing Clojure code with Java interop. Annoyingly, there's quite a lot of Java interrupt in that way. One of the reasons is that there are functional interfaces and these protocols interfaces, and basically you cannot just pass functions from Clojure like inside. You have to do reify, and the code is just getting bigger and bigger. I know that in recent version of Clojure, like maybe it's next release, or I wasn't following really, but I heard they are working on providing making like that if you pass an anonymous function into a function interface in Java, it doesn't need to be converted or reified. Maybe that will help a bit with Kafka streams, but I think they have some custom interfaces as well. So you have to do reify and implement interface method as well. So if you're looking more Clojure friendly, I know this library, and I was using that in production in a couple places, and it's fine. It has a bit of a learning curve, especially when you look into test machine and tests in general, but this API is pretty simple. So first of all, the difference between this is all stream APIs. So this JMap is not the same as Clojure map, because it will be mapping on the stream. So it's part of the stream functionality. And as I said, I'm not going to give a full introduction into streams here. So better check docs, or we can create another video, but let's just go through the code and see if we can understand what's going on. So the input topic is the topic that our stream will be configured to consume. It's a Kafka topic. Then we have this peak. It basically does nothing except that you can provide any function here, and it will be executed on top each value that it receives in the stream. And then it will return the case stream untouched. Obvious use case for debugs. Just print something here or provide any function. So you can do fn, and then you'll have the value, and you can do whatever you want. And you don't even need to return the value, because it's the part of the function to ignore what you return from the function. Part of the peak. Yeah. Then we have the map. So now we, if you go to docs, you will see that they call it key value mapper fn. And that basically means, if you see something like that, that means that you need to provide a function, and it will get one value, but you can destructure it with like an array, and you'll get your Kafka message key as the first argument, and then the value as second. And here I'm just getting the name from the value. Name will be a field in our input topic, and I'm just concatenating it with hello, and keeping the same key. Then again, debug message, and do 2. And this is basically instructing Kafka stream to write the output of our topology to the output topic. And after that, you basically return the builder and you use it. So now we go into this start Kafka stream. So I tried to make it generic so I can use the same code for different topologies. So I just provided this topology fn function as a builder here, and I'm calling it right here on the streams builder to keep it a bit more reusable. And then we have our generic Kafka config. So it's pretty simple here for streams. So we have Bootstrap service, you always need them. Then you have application ID. For streams, you need application ID. For plain consumers, it will be just group ID. Then I created this ID and always add unique UID at the top, at the end, just to make my life a bit simpler in terms of tests. And if you want to rerun that, so you always get a fresh like consumer group ID, and you don't have any unexpected behavior. Out of set reset earliest means that we will subscribe to our input topic from the beginning of time, and then you need a default serialization for key and value. And yeah, just for simplicity, I used provided EDN third, so the input in key and value should be valid EDN string, and it will be parsed into Clojure structure, data structure. There are different thirds available. Obviously, the most commonly used is JSON. There is also something for Aura if you're using schema registry. But yeah, the most used third I've seen is JSON for sure. EDN could be useful if you have only, like Clojure services. But if not, it will be a bit tricky in non-Clojure services to read your EDN data structures. So this is how you create Kafka config. Then we create our topology, and then we create Kafka stream with this library again, jkafka streams, topology, and Kafka config. And after that, you run your stream and return it. So we just want to return it because later we want to stop it. And in that test, I decided I'll just go with a simple approach here for tests and just use with open. The reason for that, because the Kafka stream is closable. So if we go into here, we will have this function close. So I've just wrapped it with open. So when the test finishes, it will automatically close the stream and stop it. This is obviously a huge simplification for demo. In real service, this Kafka stream most likely will be a component in your system or component in like an integrant. And usually we'll just start here your full system under test, and it will start your Kafka stream. And you can create a fixture for that. I've mentioned that in a couple videos, so if you search in the channel, there should be about component and how you structure your code with it. So that's the first thing. A bit of setup that we need here is the library expects your topics to be configured like this. So you need name, and then you need your thirds for key and value, and then partition and replication factor, which is all like Kafka properties. Just for simplicity, I decided partition count is 1 because I don't want to deal with that here. And then topics, and we have two topics, input topic and output topic. The next thing is they provide a fixture for topic creation. So as you can see, what we're doing is we create topics for the topic config, and we're using this Kafka admin client. And as that's a fixture, we want it once for our namespace, and this is the topics we want to create. So after that, we have a test, and this is when things start to be interesting, because this test machine could be a bit hard to understand if you first time looking into that. So again, that's a part of this library, Jackdaw. And as I said, a bit of learning curve, but it's quite handy because what you want to test in your Java, your Kafka Clojure test usually is you want to produce some messages into input topic. Then you want your running Kafka stream from your system or just start it like this to process that event. And then you want to wait on some result. And regarding Kafka streams, the result is usually produced into output topic. So we're kind of testing from Kafka to Kafka. That's the point of the stream, right? The problem is that it's not, you basically don't know when your application received the message and finished processing. So I've seen different approaches like thread sleep, which makes tests really unpredictable, and then some waits, retries, and all that stuff. So this test machine basically will create an interface for you to do this kind of assertions and expectations. So you create this test machine, again with open, because inside it needs to create Kafka producer, Kafka consumer, and then you can instruct this thing to send messages to your Kafka topics, and then read messages from your output Kafka topics and wait for a condition to be true, obviously with a timeout, so you don't wait in your test for ages. And when the condition matches, it basically unblocks the thread, it returns the result, and then you can validate your results in your test. And to create this, create messages, you have these writes, and to watch for output, you have this watch command. Here we create two commands for this test machine. So first one will be to write to input topic this message with this metadata. So the metadata could be in different shapes. So you can just say what key you want for your message, but also you can provide a key FN that will calculate your key based on your test message. Also, you can just set partition directly or partition FN, same logic as key FN. So here I just wanted to partition 0 as we just have one partition. And then the watch. So there is a concept of this journal, and it will basically record all your state changes in your input topics and output topics. As you configured your machine to be with these topics, it knows which topics to look into. And what we say here is we just basically want the first message that we receive in the output topic. So when this function is basically called in like a loop, and the timeout is when it will give up and terminate with an exception. So if timeout happens, your test will always fail with unhandled exception. So, but when this will be true, this will finish, and we will continue with the test. We'll get our results from the run test. And as you can see here, we just run tests on the machine with a sequence of commands. If we just have one write here, but we can create a second write or even like second watch with different conditions if we want. But this test is kind of simple. So when this will finish, we'll get results. And after that, we can destructure our results per command. So as you see, it's an array here of 2 commands. So it will be an array here as well with the results. So first argument will be write result. As we don't need it, we can just ignore it. But if you have a second watch, for example, watch 2, it will be second result. Like the names, they are not named, you just name it in the destructor list. Right? And for the assertion, I just want to check that, as we see in the logic, the name from the message should be converted into hello and the name after. So yeah, let's try to run the test and see. Quite a lot of output by default, but you can configure your logging properly and just reduce that. As you can see, tests are passing. That's fine. And now let's change just for like world. And now we're failing, obviously, the assertion, right? And yeah, let's fix that. Run again. And yeah, test is passing. And the second one, I promise it will be a quick one. Same setup. We create topics like this. We create our topics fixture to create the topics themselves. We create a test machine with open with this Kafka transport and our Bootstrap service. I remind you, we always talking to this real Kafka here, which sits in our Docker container. And then we start our Kafka stream. And as I showed you, we pass the topology FN, and topology FN is getting topics and builder. But here we just provide builder, and that's why I'm using here the partial. So it will be topology and the topics that we use in tests. So this will return a new function, and we pass it here to create a topology. So here we have different writes, and this is an example with two writes, really. The first message is this, second one is this. So in the input topic, we'll have a message with a key line, and then you have a string with spaces, and then a second message with different content. And in the watch, we again checking the output topic, and we're removing nils just in case if we got some nils there. But really what we expecting is we want 8 messages in the output topic, and then we say that this is what we want in our tests. Why 8 is because it's like 8 elements, 3 plus 5. And we'll see in a sec what we are going to do in our topology. Let's jump into it. So here again, we create a stream on top of input topic. Then we do some debug lines. Not really interesting. But after that, we do flat map values. So here we provide not key value mapper, but just value mapper. It means that we ignore the key. And in that case, you just want to pass a function with just value as an argument. And then we do split by empty space the line key. It will be an array as a result, and that's why we use flat map to convert it into stream of individual events for each of these values. So here we do another call from Kafka Stream API to group by. Again, this one expects now key value mapper. So you have to do this destructuring and ignore the first argument because we're not interested in the key here. And we just want to group by value. So the value will be our individual words from our lines, but in our case, just letters. And then we do group by, and it will group it by our distinct letters or words. And then we do count. And this is getting interesting because this is a stateful Kafka stream because it knows what happened before. It knows that, for example, it's in the word letter A or whatever, or any other word. It's in it once, and then next time it receives it, it will be like 2, 3, 4, etc. And then we need to convert it back to a stream because this is a key table, I believe. But yeah, again, not a deep dive into Kafka streams. And then we do some debugs as well and do it into output topic. And let's see what we expect in the test. So this happens first, this happens second, right? And in Kafka, we have the order of the messages as they were written into a topic. So after this was flat mapped and split it into individual words, we'll get A, B, C, and then these letters. So now in the output, when we do counts, the value will be the count of the words that we encountered. So for the K, A will immediately produce the message with the value 1. Then we get B, value 1, C, value 1, and then these three, value 1 again. And then once we receive A again from here, we now increased our counter and we now have 2, and B as well, 2. So let's do something like, let's run this test. Yeah, and yeah, you see it works. So for the watch result, I just want to briefly show you. It actually has a lot of information inside. So if you need something else, you definitely can try find information there. It's really big. So, and that's one of the issues with the library. But on the other hand, it's powerful as well. So, yeah, you see all this duration, finish that, whatever, all meta information, params, journal state before, and yeah, like status, result, found, all that stuff. And also, I think it's here, but I could be wrong. Yeah, so it results in journal here. So let's do destructuring. And now let's print this thing, which will be really huge. So yeah, as you see, it's the state of our Kafka topics at the end of our test execution, which is really handy for debugs and all that stuff. But yeah, I really hope this video gave you a bit of value. Obviously, as I said, it's not like a tutorial on Kafka streams, so you need to understand what's going on. But yeah, writing your Kafka stream in Clojure first time could be a bit, a bit hard, but hopefully you'll get an idea what to do now. I'm going to cover more Kafka topics later. I've been working with Kafka for many years now, and there is some really interesting topics to discuss. Especially one of the recent ones is a nice library from Confluent for the advanced consumer, which is called the parallel consumer. And I think we'll talk about that in one of the future videos, how you can increase your performance in consumption of messages without really scaling your topics in terms of partitions, which could be sometimes really useful. So yeah, that's it. Thanks a lot for watching and for your support. I recently reached 1,000 subscribers on my YouTube channel, which is a huge milestone for me. And as usual, there are links to buy me a coffee and support my work if you want. Have a nice day. See you next video, and bye-bye.